Okay. Welcome, everybody. I hope you're having a great time here in droidCon, New York so far. Nice. That's good. So we're going to be talking about app development, some practices. Let's not say they are the best practices. They are good practices. You know Yiğit, for sure. That's it. I'm not going to say anything else.
Go ahead.
And I'm Israel. I work at Twitter, and he works at Google. And that's it. So the problem we were facing when we were doing this talk was like, okay, so it's a really broad topic, what we are going to talk about. So we decided to do this survey. We got 150 answers. And through them, we realized that the most interesting ones were the ones that talk about the difficult and bad parts of your app. So I'm going to talk, we tagged them, and we got a sense of what was the biggest issues for everybody. The first was architecture. The second, under the specifics, shocking. And then what about the recurring problem in your code base? Testing, code flow, which was a different topic, but similar in a sense. And then second, it was architecture. Then finally, the other one was what design patterns you would like to replace from your code base. We got a lot of data, but 61% of it was actually pretty common. And it was God classes, God activities, MVC, MVP, MVV something. People just hate everything, all the architecture.
I like these are the stuff people want to replace.
Yeah, they wanted to replace everything. It's like, okay, guys, just do something and try not to hate it. Lack of architecture, singletons everywhere. Singletons was really popular, was top 3. I guess.
In both sides, that they really like.
Yes.
Someone really hates them.
It was really interesting. So I guess we are going to be talking about a little bit of architecture and how we build a foundation, a good foundation.
Okay, so it was obvious when we look at the results, architecture. There's actually, like, I want to take one step back talking about it, like why architecture became so popular in this like last 2-3 years in the Android community. First of all, it just became popular. It was always there. And I feel like the reason for this is, as an ecosystem, we are more mature now. Like, we don't deal with simple problems. But as we become more mature, the user expectations get bigger and bigger. Now you need to deal with more complex problems than more primitive problems. And also, like, the ecosystem just got better. Our devices got better. Like, for example, art is so much better than Dalvik. Like, things like that are really good for architecture, like for separation, things like immutability. If you try to do it on Dalvik, it will penalize you significantly. Versus art is like, you know what, I'm pretty good at garbage collection. You better not churn objects, but if you churn objects, I'm not going to penalize you too much. So as part of this is technological advancement, literally, making some things more feasible. But if you look at, so this is a screenshot from 2010 Gmail application. Like, how, I don't want to say ugly, but like,
Material design really good here.
very material.
Sorry, I know, I was joking.
So like, if like, obviously writing that application was very, very hard. Like, I don't think I will be able to. And then the constraints, like, look at, these are the important things for them. It still needs to work offline. And this is 2010, like the networks were even worse than today. And they're slow. And your application only got like 32 megabytes of memory. That was 16 before, then became 32. It's like, as a comparison, if you put a full screen bitmap on your Pixel XL phone, that one is 40 megabytes. So you can put like 2 bitmaps, and you have like 4 megabytes to spare, and that's it. So like, things has changed significantly. But like, also the user expectations were different. Like, okay, it was hard to do these things, but I pulled a comment out of that blog post in 2010, and one of the users says, it works on my Evo 4G. I don't know if anybody remembers this device. I don't. And then here's a comment. This person says, are you planning to add zoom functionality? This is the thing that you always like pinch with your fingers. You're so used to it and expect it to work everywhere. This person, like, do you have any plans to add that feature? That's a feature. And their reasoning is everything is becoming HTML. So this user doesn't even expect to see HTML emails on their phone. But just thinking that this is the feature that will be really cool if you guys start supporting it. That's where the user expectation is. And this is from 2010. So if you're writing an application like this those days, you need to write all of the networking code. There was nothing out of the box. You need to write all the image loading and caching. And then you need to create these view fragments because there are no fragments. Even though people hate it, lack of fragments is...
Loaders and
loaders.
content providers.
Maybe that was loaders. Like you basically need to write everything. And on top of it, your APK needs to be very small. So that was like the early promise of Android, that like you get all the Java libraries. We suddenly realized we don't really get any of them because none of them is optimized for Dalvik. If you fast forward today, you don't write any of these libraries. Like everything is already given to you. Just pull the right library, pull the one that you prefer, and then you just focus on writing your application. Of course, your APKs get bigger, which slightly more okay for them to get bigger. And if they're really, really going big, we have things like split APK, so you can divide your code base. So like those primitive problems, I call them like basic problems, they're already solved today. So you don't spend time with them. So in those years, we were focusing on like doing basic things. Like in the work I worked before Google, we wrote our own image loading, we wrote our own networking, like we wrote everything. You don't write them now. But now you need to spend all your time developing these complex features. So if you look at Inbox application, which was shipped in 2014, I guess, or 15, like that needs to render 60 times a second. It has a lot of functionality. If you look at that thing, like the amount of stuff you can tap on that screen is crazy. It has integration. It knows my flights, my notes, it understands my email. Like there's a lot of work going inside it. And like a part of that UI is full HTML because that's the expectation. That's what the other party sent. And I want to talk about something very, very interesting here. So if you look at this UI, there are multiple HTML elements. There is basically in every cyclery row. If they need to display HTML, they just put a web view there. You know how they did it in Gmail? It's a video we recorded from Gmail. Can someone realize what's going on there? It's like someone's pinching that screen. So what's happening there is, there's a list view. I don't know if you switch to a second. There's a list view. Behind there is one giant web view. As you pinch it, they are synchronizing the list view with the web view so that you can get along by just using one web view. Like, this is the kind of crazy optimizations you had to do to make things work. And today you can afford not spending time on them. I was amazed at how they pulled that off.
It's a really nice workaround.
Yeah, this view was better.
Yeah, they're smart.
And it does work offline. It has this rich text tensor. Whether like it's full of features. So it's just that we have a different problem. Now we will focus on writing more complex applications. Of course, you do need a better architecture. So if you're someone like we're trying to figure out, okay, how like it's a super complex problem.
Can you give me some advice?
Said Israel. Forgot your name.
Yes, it's like the country.
Yeah, the country asked me. And I'm like, I have no idea. I really have no idea. And then there's just so many things I barely know half of them. But like, one thing I can tell people that you need to be doing is the separation of concerns. So just like something very simple that you need to stick with, which is stuff you do is independent from what other things do. Like when you're writing code, your components, modules, classes, whatever the unit you have, try to make sure it just tries to do only one thing. It doesn't try to deal with 10 things at the same time. And this is the only thing that you need to stick in day one. Like, don't think about MVV, MVVM, clean, whatever. Like, just forget about all of those things. Just as you write the code, as you need it, just make sure it just deals with one thing. And then you will, over time, start grouping these things. And then you will build your architecture on top of it. Like, you can, of course, read all these other architectures, try to understand. But from day one, I mean, personally, it's impossible for me to understand what is the best architecture for an app because, like, I didn't even write it. I don't really understand what the problems are.
It's complicated. It depends.
Yeah, it depends. Like, so what do you do if it depends? You just be careful to write your application in a modularized way so that you can flex it to better suit your needs in the future. It's also like kind of like recursion. I know when you like start learning computer science, recursion is this weird concept where like there's a large problem, you know how to solve a like small part of it, your base case that you know how to solve, and you assume the rest is solved. It's very similar like that. Like as you write your application, you try to make the problems you deal with small. You assume the rest of the application is also in small pieces. And then you can reduce those cases into other small cases and solve them. And while doing this, like the reason why I tell people try not to do it in the first day, instead do it over time, is if you try to do it in the first day, you will likely to over-engineer, which is really, really bad. Like all these libraries you end up using, things like RxJava, Dagger, whatsoever, they are really tools, but because we are engineers and we really like to geek out on stuff, we just like make them our goals. Like how do I Rxify all of my application? Like you forgot to ask the question, should I Rxify all my application?
I think at this point, this quarter is going to be Kotlinify your...
Kotlinify, yes, sorry.
Like the quarter roadmap, yes.
Yeah, so like you need to always think about this because all you're trying to do is to ship an application. Like you want it to be stable, and then you want it to be maintainable so that hopefully if your startup, whatever, succeeds, you will keep working on that. So those are the two things you're trying to achieve. And while trying to like achieve these goals, when you see that like fancy blog post about how someone is using, like Lisa is using data mining, though that's awesome, we should use it too. Well, no, like, you should look at their problem, and is that the same problem you have, and then you should use that technology. You can experiment with things that you should experiment, but like, please do understand when someone writes a blog post, including myself and Israel, you just try to make it look like the best you can make it look like. So you don't think about, well, I have this solution for this use case, but it doesn't work these other 50 cases. No one mentions the other 50 cases. Yeah.
Oh, that's definitely true.
Yeah. So keep that in mind. And what do you think is that?
Yeah, so I wasn't satisfied by your answer when we were doing this slide. So I was like, okay, I want to give my recommendations since I do a little bit more of app development, just a little bit more. This is my recommendation. And that stands for whatever it works. Because everybody hates them, all of them anyway. So I was like, okay, so let's talk about something else. So it's not a dogma. What I recommend you is apply principles with consistency when you define them. And principles can evolve. They are not written in stone. And what I recommend you to do is dependency injection. Why? Well, because it allows you to declare the dependency up front, and that has benefits like testing, which you should do all the time. Okay? I learned from another talk yesterday that I have to make a dramatic pause. Thank you, Pierre. Sorry. Anyway, so single responsibility, that's really important. One reason to exist, one reason to modify a class. It's similar to separation of concerns, but separation of concerns is just a class that does one thing, like DB manager or whatever. Manager is such a bad name, but yeah, DB handling something. But then you do different things on the database, like you want to handle different types of repositories. So you have database, you have flat files. So you are going to have one class per each of type of storage, right? So that's what I mean by single responsibility, a class that has one reason to exist. And then I recommend you to have a layer architecture with a single responsibility in every layer. First, this view looks really bad. It's better in the laptop later. You can check it out. But it says view layer, meaning the view manipulation, do it in that layer. Only modify the UI that you're going to be showing. Then the second layer is the logic layer, meaning the features, the actual behavior of your screen. And then finally, the least but not last, because that's important, otherwise I don't know what you're showing the screen, is the data layer. And for the data layer, please follow this recommendation, which is have a clear interface between your data layer and your screen behavior. Therefore, if you change your database scheme or your network layer or any memory and cache system that you're using, the implementation doesn't matter. What you really care about is that's the interface between the screen behavior and the data layer is going to be constant. And then at this point is, okay, so what happens when I have a really complex screen? Well, what you can do is you can just divide single responsibility, small components per each behavior in the screen. And then, okay, but most of times they actually have to communicate each other because they depend on other components in the screen. Okay, then you have to figure out some type of infrastructure. You can use RX or you can use event bus. Don't use it. And then there is another problem. There is that problem where you have multiple similar features in different parts of the application. How do you reuse them? For example, liking a tweet. You can like a tweet on a timeline. You can like a tweet on a highlights. You can like a tweet on moments. If you don't know what it is, install Twitter and use it, and you will see where it is. But that's pretty much the same logic, right? It has to do a request. It has to get a result, and then it has to show an increment on the UI. So the UI is different, but the logic actually is the same. So what I recommend you to do is the logic layer, you break it, sorry.
You buy it.
Great English. And you will have a use cases layer, which that is going to be like a plugin. You're going to have, the screen behavior is going to be an interface really between those use cases and the rest of that architecture. And of course, those use cases will need to have some data layer component too. But doing it this way, you can just use the like tweet in many different apps of the Twitter app, for example, right?
By the way, like this is a good example where like you don't do it from day one. When you realize you need to share this thing and then you try to solve that problem. Like trying to solve a problem before it exists is a really bad idea.
Yeah, if you do that, you're going to solve two problems. First, the problem that you are making and the problem you're having. So just try to take, try to do baby steps is always a good idea. So to sum up, each layer has to have a reason to exist. There has to be a consistency in your code base from the moment you define those principles. Otherwise, when you work in big teams, it's going to be some type of communication with some other people in order to understand their code base, which is okay, but if you want to minimize that, that's great. That helps you to make the logic layer testable. And if you add that extra use cases layer on the layer logic, then you're able to reuse that logic later. A lot of logic. So let's talk about Android specifics with Yiğit. He loves them.
So I happen to work in the Android team.
It happened, yeah.
I should know about this. So we hope I hope we could address something about the architecture, and my main point there is just like stop caring about it too much. It will be fine. Android specifics, not that much. You have to care about them from day one. And then life cycles was in every single answer, pretty much. Everybody hates them.
Everybody loves it.
It's like love or hate, like it's like Spanish love.
It's that type of relationship, yeah.
By the way, by the time I think we did this like poll around June, that was like slightly after architecture components, so maybe they will get better. I hope. But on the other hand, the problem I'm a little bit annoyed is this is a solved problem. Like life cycles on Android, it's hard to understand when you are new. We get that, but there are so many solutions. And I'm trying to figure out how do I explain this. I thought, you know what? I will just talk about the solutions. And there's like so many solutions out there. You don't need to really think about them. You pick one of them, you apply it properly. But like part of I think the main problem it comes is people's code don't have the proper separations or the layering or whatever you call them. And then you put everything together. And of course, you cannot handle life cycles because Android is constantly trying to kill everything you have. But
Stop it, Android. Stop it.
I have no memory. You shall go.
Buy bigger memory, Android.
I can get the new Pixel phone. So, but imagine we have proper separation, right? Like this is what we try to put in architecture components and everybody else talks about the same thing. But if you have the separation, then the life cycles actually becomes only a very tiny little part of this problem. The rest of your code base doesn't need to know about life cycles. So you basically reduce the problem by adding separation and nothing else. Now there's only one part that we need to deal with life cycles in our application. I wanted to go through like 4 options, but there's probably 10 or 15. I just pick 4. And then we'll just go through them very quickly. I want to show how similar they are. The first one is, of course, manual, because no one can write it as good as you would do. And let's do it that way.
Is that true?
Of course.
Okay.
Well,
Yeah. Do it yourself.
go through it. So if you're doing it that way, if you go back to, like, if you remember the previous slide where we had this V model, that's the thing where the data lives. So we provide it in some sort of observable way. Doesn't matter what kind of observable. That can be Java language observables or RxJava data binding, doesn't really matter. But we have a list of users that comes from the V model that we can observe. And so in our fragment or activity, we get a reference to that V model, and we do have a subscription. When it starts, we subscribe. When it stops, we unsubscribe. This is like the simplest case of handling life cycles, and this works fine. Little bit boilerplate, but that's okay. But what happens, so we need to, of course, spice it up a little bit. What if we want to subscribe only after user clicks? Now, I'm using click as an example. You can replace that operation with asking for a permission, waiting for a network request, talking to another application, doesn't matter. Something asynchronous. Well, that's not that hard either. Thanks to Kotlin, you can just write something like this, like subscribe only the first time you need to subscribe, and on stop, just unsubscribe. This seems fine, this seems easy, but actually that doesn't work. So this code, there's a chance that this code is going to run after you unstop. And I'm using click here again as an example because no one thinks that a click listener will come after fragment is stopped. Unfortunately, that does happen because click ending is an asynchronous operation. So you need to work around this problem. You need to handle this. Otherwise, you will get these fragment transaction exceptions. It's not too hard. You can just say, get my lifecycle. If I'm at least started, do it. Otherwise, don't do it. But of course, this code gets more and more ugly over time. It's not very scalable. Alternatively, you can use data binding. Now, data binding, because it's for Android, it already knows about lifecycle. Your V model is slightly different, doesn't really matter much. In the base case, you say, well, when we create, just give that observable to data binding and let it take care of it. And that's actually all you write. Data binding already knows how to not to leak your activity or how not to observe. Everything is built in, so you don't care about these problems. For the click case, it's actually very similar. Even for the click case, again, you don't need to think about your lifecycle. Data binding knows how to think about it, or it knows how to unsubscribe from the previous entity and subscribe to the new one. Of course, this example assumes you have some binding adapters or whatever, but whoever uses data binding have them usually. Let's go into the more newer ones. If you do look at the same problem in live data, it's very similar. We have a live data of list of users from our model. And now all we do is, when the fragment is created, you say, OK, just bind this to this method in the adapter, and you're literally done. You don't need to do on stop, on start, because we know everybody needs to do it. So instead, live data does it for you. For the click example, it gets a little bit more tricky. Now you need to avoid resubscribing to the same data. So you need to hold on to the subscription. But that's, again, the only thing you care. You just avoid resubscribing, and whether you are stopped or not is already built into the logic. So you don't need to think about it. If you are using RxJava, by the way, if you're already using RxJava and you learned it, there is no reason to move to live data unless you just want to make it simpler. But if you are using RxJava, just use auto-disposable. Please don't do these things yourself. This code is almost the same as what you do in live data. You have some observable. You say auto-dispose this with this lifecycle, that refers to your lifecycle. And then that's all you do. You don't do anything else. It automatically disposes. So it's all these 4 examples I looked at, they're all doing the same thing. These are all solved problems. If you are having problems with lifecycle in your application, you probably invented it because you need to do it 5 years ago, I understand, but you either move on to a modern solution or you fix yours to use the same way these things work. So I don't think lifecycle should be a problem anymore. On the other hand, configuration changes is a little bit weird because it just doesn't really exist on the web development. I don't know how much it exists in iOS. But I want to clarify something here. Configuration changes and app restart are like totally different things. I see people try to solve these problems together. It doesn't work because they're different problems. Like to handle configuration changes, which is the case when you rotate your phone or the language changes or a keyboard gets attached, all you need to do is decouple the UI and the data. But just sticking a view model to that activity or fragment like, brings you 90% of the way, and then you are more or less configuration change resilient. Versus if you want to handle app restarts, your UI needs to come from the disk. This is one of the problems we are seeing in the answers. People are having problem handling next billion users because your application happens to get killed a lot more on those devices. So your data this is why we always say your data has to come from the disk. And then the other part, you can just use a V model to solve the configuration change problem, but to handle the restart, you need to start using the saved instance state. By saved instance state, I mean all the get intent, the intent parameters, or the fragment arguments, they're all the same thing. Now we try to go through like a practical example. So if you have an activity like this, you put everything together, Android comes out, oh, I need to recreate you, and it kills everything you have. Of course, you will have problem handling configuration changes. But if you have something like this that gets decoupled, when Android comes to kill your activity because your resources might have changed. Nice, good. he picked the emojis.
You don't want to know the other one.
Yeah. So only the activity will die, your repository, your memo, everything survives, so you will be cool. By the way, don't use the option you have on your device in developer option that says kill background activities. That's a case that never really happens. Like Android never kills an activity without killing the whole process. So use that option sparingly. So in real life, this is what happens. And just like when that happens, all of the Android views already know how to restore their state. And if you use something like a view model, all of the data is there. You basically don't need to do anything. You just give the data back to the UI, and everything recovers. To handle application restart is a little bit different because you're dead, like nothing in memory survives. So if you didn't put that data into disk, not into saved state, into disk, they're all gone. So that's why the MBU was hard for people. But to handle this application restart problem, there's actually two important actors that we didn't look at in the previous one. One is the saved state, the other one the disk. Saved state is the minimum amount of information you need to recover the UI state. This is like the example I give here. That's the user ID. It's not the user object. You should never, ever put the list of search results you are showing into saved instance state. That's not that big. You will crash. And the actual data lives on the disk. So if you want to look at a practical example where we show a UI that shows a user profile, so let's say that we came back to the application 5 days later, the UI comes, your activity goes to save state, grabs the user ID, gives it to the V model. V model is like, okay, I'm pretty new, I'll give it to the repository. Repository goes and say, okay, tells the disk because it knows the user data is in the disk. And then it also gives it to the network you probably want to refresh. So network turns it into a user, disk turns it into a live data of a user or exchange of a user, and then gives it back to the repository. The important thing here you need to understand is whatever comes from the network that goes into the disk, it never goes back to the UI. This makes the disk your single source of truth. Anywhere that this changes, your UI always shows the latest information. If you start pulling this, like if you do this actual operation, pull from network, pull from disk, whoever comes last, return it to the user, you are doing it wrong. So this live data travels back to the V model, comes to the activity uses it, and then user rotates the phone. Now we need to go through a configuration change. Well, a new activity arrives, goes back to the save state again, grabs the user ID, gives it to the V model. V model is like, oh, I already have this user. There you go. This is why when you rotate the phone, like everything recovers very fast. You don't actually need to go to the disk. So everything looks smooth and then works. But how does the fragmentation work, amigo?
Well, my friend, I don't know. No, I'm just kidding. But we don't have much time, actually, so I'm going to go really fast. Types of fragmentation. hardware, screen sizes, densities, SDK version, and OpenGL even. I'm not going to talk about OpenGL because I don't know much. You can ask Romangi. He knows everything. But let's talk about screen fragmentation. So screen fragmentation. This is pretty much Android 101. So you should know. Especially use constraint layout at this point. Okay, no need to use relative layout. Constraint layout does it better. Let's talk about hardware fragmentation, which I think is a little bit more interesting. First, the way you do that is you create a profile for the hardware, and then you can be as granular as you want. You can have low, medium, high performance, but you can have more. And a good way to start building this type of category of hardware profile is by using actually Facebook device year class, which is pretty good. And then by going to your analytics, you can figure out what of your devices are actually crashing because they don't have enough memory to run your application, and you put them on low, medium, or high profile, or if you have any other profile. Then you can do this sad thing everywhere. Imagine you have this animator that runs animations, and all the time that you want to run an animation, you're going to have this when all over your code. Don't do that.
Still Kotlin size.
Yeah.
Still nice.
It's nice. It's Kotlin, yeah. It's nice. That's the quarter goal, writing Kotlin, everything. Anyway, so animator, to define this interface, and what you should do is have this type of factory where depending on the profile, the hardware profile you have, that you are only gonna get in activity on in application construction because the hardware profile is just the same for the whole application. So you just have that in the context, in the application context, and then you get it on all these type of factories that depend on the performance of the device. And then what you're going to do is just create an implementation of that animator that depends on the hardware profile. And then you just put that in your dependency graph tagger, and then you just get it when you need it. Something like that. If you don't want to, yeah. You get the factory, you pass the profile, and then you run your animations. Then sticky fragmentation is similar. You do the same. It's what actually AppCompat does.
Yeah, just look at the Weave Compat class.
Yeah, so just it's the same.
Solve problem too.
Yeah, it's a solve problem.
Why are we talking so solve problems?
It's fine. It's all fixed. There are no issues here. I don't know why you're here, actually. No, just kidding. No, I'm just kidding. So now let's talk about one of the questions in the survey was, what is your favorite library? And we got, surprisingly, Retrofit, the most popular one. I was expecting something else. But Retrofit was the most popular, but by 60%, which is like amazing. But I want to talk about dependencies that actually change the way you code. Libraries that change the idioms in your code and that maybe they are not free to use. They have some cost associated. So let's talk about RxJava. RxJava is fantastic. Awesome.
By the way, RxJava was also one of the top most hated answers.
Yes, that too. It's really weird. There were really mixed feelings in everything. I was just really confused. So yeah, so we got this text view, and everything is functional, Fluent API. You get a reactive push. You get built-in operations. You can easily declare the threading, and then you can subscribe and handle different types of cases, right? That's great. That's all fantastic. Then you have this. All the operators. Boom, boom, boom. Come on. Yeah, we just finished. So I like this. So with great power comes great responsibility, and that's real. Like RxJava is a superpower. It's fantastic, the kind of complex things that you can do. But at the same time, you have to be aware that you can really break things if you don't understand all the operators that you are using and how you are using it. I don't know if you want to add something to RxJava.
It's cool.
It's cool. It's really cool, actually. It's really, really cool. But, so be careful with the superpowers. And now let's talk about another superpower, which is Dagger 2. So Dagger 2 is amazing. It's how it generates all the dependencies needed for object creation. It's code that is readable, programmable, debuggable, traceable. It's really well built in for Android. And it's magic. It just does everything. It's fantastic for dependency injection. It's the best option. Really performant. But you have to build a dependency graph, which it may be easy, may be difficult, but that's a thing that you have to know. And at the same time, you have to learn the DSL of Dagger, how it actually works and how it does build the graph. And to do that, I'm not going to go through. I was going to go through, but we don't have time, so it's just, annotation, 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 annotation. And there are many more annotations. They all have their meanings. There is multi-binding. There is something new for Android injection. Change it from the last API. It's great. You just have to learn it. You and everybody in your team. So just so you know, it's the best option, but at the same time, it comes with a cost. So I had this example, like let's imagine we want to build a tweet actions component that allow us to reuse all the Twitter actions in the different parts of the application. So first you have to use this component thing from Dagger, and then you have a network module and a DB module. And then you have the Twitter actions module where you have the actual code that does the network request and change the UI. This is actual code, not annotations. And then there is the timeline that uses these actions. And then you have another application component that bridges everything. Probably not perfect.
Yeah, all of this to send a tweet.
Yeah. Yeah. Maybe, probably no, probably works. So warnings. So they are fantastic superpowers. They are perfect if you want to scale your app. It comes with a cost, learning the DSL, except if you are Jake or Ron or that's it. Or you work at Dagger at Google, then yes, you can use it. It's easy. And that's the problem, right? When you hire new people to the team, if they are not really experienced, then that's what we have, that they have to learn it all. And then custom frameworks, the same with custom LAN. I want to be really fast. We have 2 minutes. This is going to be great. So, those are provided. There is an open source option. Do you really need to build your custom framework? It's 2017. It's not 2010. So think about it. And when you commit to build your custom framework, you have to maintain it too. And at the same time, newcomers don't know about it because if it's not open source, they don't know about it. So now let's refactor. Do we have time to refactor?
Actually, we don't have time.
Okay, so we don't refactor.
So
that was a really good joke.
there's no time for refactor.
But for real, we don't have time.
We had some ideas, but yeah.
Yeah, we have some ideas.
No time for refactor.
We'll
But
share the slides.
There's only one thing about refactor. There's some people thought about this problem. They're important things. Just do it slowly, whatever. There's only one thing that's important. I want to talk about testing. If you want to refactor, you need to have tests. If you don't have tests, you'd never do this. Oh, I'm going to rewrite this section. It will be all of with tests. It will be amazing. No, you cannot do that. If there's a section that you want to refactor that doesn't have the test, you first write the test using the old code, and then you refactor it. Otherwise, you're just like fooling yourself for no benefit. And actually, we also don't have time.
Well, we don't have time for you this. Classic. This is a classic, but really, you should all test your logic layer. That's why we talk about it, to have a layer architecture. You should at least be sure that your logic works. Then if it's impossible to attest, that's because legacy code. Use Espresso Test Recorder so you can do the refactor but know that the UI is still working properly. For that, you have to use, this. So
wait, this is the important one.
This is really, really important. One more thing, okay?
Best answer.
These are the best answers. We don't know who did it, but it's great. What is a recurring problem in your code base? The keyword. I guess it's related to how difficult it is to actually show and hide the soft keyboard. I guess, which it happened to me many times. It wasn't me, by the way. Patterns you dislike and I would like to replace in your code base. That could be me, but it's not me. Hungarian notation.
Okay.
This is the
you get used
favorite.
to the Hungarian notation. It's not too bad. It's my life right now. Don't make me feel bad.
Take the stage for this one, please. This is really important for us.
This is the best answer we choose. What is the best part of your code base? Thank you, everybody. Thank you.
There you go.